What if the universe had shortcuts? Not faster spaceships, not warp drives, but actual tunnels through space and time itself. Imagine entering a doorway near Earth and appearing instantly on the other side of the galaxy. This idea is called a wormhole. For decades, wormholes have appeared in movies, science fiction, and theories about interstellar travel. But here's the shocking part. Wormholes are not completely fictional. Some equations in modern physics actually allow them to exist. So today, we're separating science from science fiction. What are wormholes? Could they really exist? And if they do, could humans survive traveling through one? A wormhole is a hypothetical tunnel connecting two distant points in spacetime. To understand this, imagine spacetime as a flat sheet of paper. If you travel from one side to the other normally, the journey is long. But if you fold the paper so the 2 points touch, you can cross instantly through a shortcut. That shortcut is basically the idea behind a wormhole. In physics, wormholes come from solutions to equations in general relativity. These equations describe how mass bends spacetime. It also explains how matter and energy shape the geometry of the universe. And surprisingly, some solutions mathematically resemble tunnels connecting distant regions of space. These theoretical tunnels became known as wormholes. The first serious wormhole concept appeared in 1935. Albert Einstein and Nathan Rosen studied strange solutions in relativity that connected two black holes. Their idea became known as the Einstein-Rosen bridge. At the time, they weren't trying to invent portals for space travel. They were exploring the mathematics of gravity. But later scientists realized these bridges might theoretically connect distant parts of the universe. The problem? The original Einstein-Rosen bridge was unstable. It would collapse too quickly for anything to pass through. Not even light. So while the equations allowed wormholes mathematically, surviving inside one was another story. If a traversable wormhole existed, it would have two openings called mouths. These mouths could exist in completely different locations. One near Earth. Another near a distant star system. Instead of traveling millions of years through normal space, you would move through the tunnel itself. From the outside, the trip might seem impossible. But inside the wormhole, the path could be incredibly short. Some physicists compare it to drilling through a mountain instead of climbing over it. But there's an important detail. Wormholes do not technically break the speed of light rule. According to relativity, nothing can move through spacetime faster than light. A wormhole changes the geometry of spacetime itself. In simple words, you are not moving faster. The distance becomes shorter. Now we reach the biggest obstacle. Keeping a wormhole open. Most theoretical wormholes would collapse instantly under their own gravity. The tunnel would pinch shut before anything could cross it. To prevent this collapse, physicists proposed something extremely strange. Exotic matter. This is hypothetical matter with negative energy density. Normal matter has positive energy. Exotic matter would behave very differently. It could theoretically push spacetime outward and stabilize a wormhole. The strange thing is that tiny negative energy effects do exist in quantum physics. One example is the Casimir effect. But scientists have never discovered enough exotic matter to stabilize a giant wormhole. And currently, no experiment proves traversable wormholes exist in reality. So wormholes remain theoretical objects. Allowed mathematically, but completely unconfirmed physically. Science fiction often shows black holes as wormholes. But real physics is more complicated. A black hole forms when massive stars collapse under gravity. Its gravity becomes so intense that nothing inside the event horizon can escape. Some theories suggest a black hole could connect to a white hole. A white hole is a hypothetical object that only ejects matter outward. Together, this black hole-white hole system could theoretically form a wormhole. But there's no evidence white holes exist. And realistic black holes would likely destroy anything entering them through tidal forces. This stretching effect is sometimes called spaghettification. So if natural wormholes exist near black holes, surviving them may be impossible. This is where things become even stranger. Some theoretical models suggest wormholes could create shortcuts not only through space, but through time. Here's the idea. If one mouth of a wormhole experiences time differently, perhaps due to extreme gravity or near light-speed motion, the two ends could become time-shifted. Entering one side might allow someone to exit in another time period. This creates major paradoxes. For example, what happens if someone travels back and changes the past? Wormholes are one of the most fascinating ideas ever discovered in theoretical physics. They may be impossible. They may exist only in equations. Or somewhere in the universe, hidden beyond our current understanding, spacetime itself may contain shortcuts waiting to be discovered. For now, wormholes remain a mystery between science and imagination. And that mystery is exactly why physicists continue searching. Would you travel through a wormhole if you had the chance? Let me know in the comments.